Hi, this is CC. So let's continue to look at chapter 9. And I will share my screen with you so we can code together, which is very interesting. So the first thing we will look at is chapter 9, yes. And in chapter 9, we will look at how to actually use matplotlib to creating the publication quality plots. And the project was started by John Hunter in 2002 to enable a MATLAB-like plotting interface in Python. The Matplotlib and IPython communities have collaborated to simplify interactive plotting from IPython shell. Matplotlib supports various GUI backends on all operating systems and additionally can export visualizations to all of the common vectors and the raster graphic formats. So, for example, PDF, JPG, PNG, GIF. Okay, so let's check about it. Okay, with the Brave Matplotlib API Primer. So first we will import the convention, which is import matplotlib pyplot as PLT after running this. So in Jupyter, we can try creating a simple plot, which import np, we create this data, and then we use plt.plot parentheses data, we can draw this line. And at the same time, well, libraries like Seaborn and Pandas built-in plotting functions will deal with many of the details of making plots. So we want to customize them beyond the function options provided. We will need to learn a bit about the Matplotlib API. So right now we want to do, the next thing we want to do is figures and subplots. So plots in Matplotlib resides within in the figure object. So we can create a new figure with a PLT figure. So this is it. And then an empty plot window will appear in IPython. Yeah, like this. But in Jupyter, nothing will be showing until we use a few more commands. So plt.figure has a number of options. Notably, fig size will guarantee the fig has a certain size and aspect ratio if saved to disk. So we cannot make a plot with a blank figure. We have to create one or more subplots using add subplot. So we can do, so this one means that the figure should be multiple 2, and we are selecting the first of 4 subplots. If we create the next 2 subplots, we will end up with a visualization that looks like this. Okay, so this is the result we have. If we want all of the, you can see here we miss one, right? So this is AX4. Okay. So this is what we want. And then for the next part is that, so when we issue a plotting command like plt plot, like this, plt plot, just like before, plt plot something, okay, 1 and 0, 5, 0, 908. So PLT plot. Okay, it shows in this one, right? So it showed in that last matplotlib draws on the last figure and the subplot used, and then hiding the figure and the subplot creation. So if we add the following command like this, so we add this one. Okay, see, it changed a little. Wow. So I can even change the access here. Okay, here's the figure 2, which is very big. And what we can find here is this part. This part is a style option instructing matplotlib to plot a black dashed line. The objects returned by Fig add subplot here are access subplot objects. So this add subplot is access subplot objects on which we can directly plot on the other empty subplot by calling each one's instance method. So for example, what we do, okay, right now we have okay, let me delete all of them and then I draw it again. Okay, I think the figure size is so big. Fig size is equal to 10. Okay. I mean, that must not be the real way to do this. So let me check how to set the fig size in matplotlib. So we can see, okay, here PLT, okay, this is how we set that figure size. PLT, this one is so small, so 10. Okay, where is it? Okay, it's smaller and easier for us to look at, right? So we don't have figure 3, we only have one figure to show up. Okay. And also we change, what we do is to change the, so if we run this, we change the last graph, right? Like here. And at the same time, we will set AX1 and AX2. So let's check what happened here. Okay, so for AX1, I change it to histogram. And for AX2, I change it to scatter. And so we can actually set each like plots here separately. So which is very interesting and it's very useful. So creating a figure with a grid of subplots is a very common task. So matplotlib includes a convenient method PLT subplots. So we don't need to use all of this. What we can do is just subplots 2, 4. Okay, we have 2 row And how about 2, 2? Okay, so this is what we want, right? And so what's in axis? So axis is like this. So as the axis array can be easily indexed like a two-dimensional array. For example, axis 0, 1, right? And we can also indicate that subplots should have the same x and y axis, use the share x and share y respectively. This is useful when we are comparing data on the same scale. Otherwise, matplotlib auto scales plot limits independently. So if we want to set something, let me check if we can do this. So it's equal to, okay, scatter NP. See? Yeah, we can also assign different things to here. Wow, and also we can check, okay, how many, what's the point value? So let's look at the next part, which is, so by default, matplotlib leaves a certain amount of padding around the outside of the subplots, and spacing between subplots. This spacing is all specified relative to height and width of the plot, so that if we resize the plot either programmatically or manually using the GUI window, the plot will dynamically adjust itself. We can change the spacing using the subplots adjust method on figure objects, also available as a top-level function. So what we can do here is subplots adjust so you said that, okay, it's not defined. Subplots adjust. So I think for some, maybe we cannot use it for some low level. I mean, because we upgrade our Python version, so we cannot do anything here. So subplots adjust, how can we use it? I need an example here. Yeah, here is an example in Geeks for Geeks. So PLT subplots adjust. PLT, subject. Okay, and then so we can see that this is after we adjust it. So W space and H space. H space controls the percent of the figure width and figure height, respectively, to use as spacing between subplots. Okay, which is nice. And so we will notice that A-axis labels overlap. Matplotlib doesn't check whether the labels overlap. So in a case like this, we would need to fix the labels ourselves by specifying explicit take locations and take labels. Okay, so for next step, we next thing we will look at is colors, markers, and line styles. So this part teaches us how to write, how to draw beautiful lines and beautiful plots. So let's start. Okay, for colors, here we have X plot. So we don't have X at this moment, right? So we don't have x, we only have like x1, x2 here, but we never define an x. So in this way, what we should do is, okay, right now, so actually these two are like example, but I also want to draw something here. So I will assign something to x dot plot, okay. So let's see if there are some example that we can copy and paste. So plot, right, x is here, okay. Right now, okay, I have x like this, and plot xy. Do we have xy here? I'm not very sure. Okay, we don't have x and y. Okay, let me maybe have a data frame. df is equal to pd dot data frame. Then what we will have is, okay, no, I think x can just be a series. X is equal to PD, like series, then 1, 2, 3, 4, and for Y, so they are the same, right? Green, this is the color. If we change it to red, then it is red. And also we can change it to like KO. Okay, then we have the point. Okay, this one is quite okay, you can see this is so without any rules, right? And the color is very dark color. So we have a way to, to put the style of the line style and color together. And also what we can look at is, okay, we have line style, we have marker. So for this one, actually we have a easy way to write, like, okay, we can write like this. And also we can write it like this. So there are two ways for us to do the same thing. Okay, it cannot show anything here, and I don't know what happened. So how about PLT show? Okay, nothing show up. So for line plots, we will notice that subsequent points are linearly interpolated by default. So this can be altered with the draw style option. So for example, okay, we have the okay. So right now we have this data, this like series of data, and we can check what's in there. So okay, come some. So what's in data? Okay, it's like this. And the next step for us is to here we have key dash dash. It looks like this. And then, okay, we want to add a step on the same thing. So also we add the legend. So we notice that the access labels overlap. So we can see that when we run this, matplotlib returns objects that reference the plot subcomponent that was just added a lot of time. We can safely ignore this output. So since we pass the label arguments to plot, we are able to create a plot legend to identify each line using plt.legend. And so that's how we actually combine two data or two lines on the same plot, on the same figure in this way. And the next thing we will look at is text labels and legends. So text and labels and legends, I mean, these are like the supportive part of your figures. So you need to know it clearly. So in this way, for us, we can really to it is easy for us to check. I mean, maybe after a while, you will be very, you will don't know, okay, why I'm doing, why I draw this picture. But with the title, with the labels and legends, you will know what's this figure, what's the meaning of this figure, right? So let's check. Okay, it seems like it's so big, so we cannot check everything here clearly. So I want to change the figure size, which is plt dot fig size 10, 10, 10. Okay, it has no attribute fig size. I cannot remember how to use it again, so let me check. It's plt figure fig size. Okay, plt figure, plt figure, and okay, fig size is equal to 10, 10. Yeah, so this is the figure and figure size, and then we can look at it clearly, so we can see, okay, here how we draw this thing, and then we have text. We just want 0. So we want to change the text of x-axis. And we have labels. Okay, so see, how can we do it? Which we have a side x text, we have set x take labels here, and also we change the font size, and then we add a title. And at last, what have we done here is to So actually, this is another way to change the title and also change the X label. So modify the y-axis consists of the same process, substituting y for x in the above, in all of these code, and then you can get what you want. So the axis class has a set method that allows batch setting for plot properties. So this is how we use it. And we can also add in legends, which legends are another critical element for identify plot elements. And we can add the legends, which let's check the result. So that's how we can add a legend. Because when you first actually run this part, you cannot see the legend, but you use X legend and find the best location, then it will show us the legend. So the legend, the log tells us matplotlib where to place the plot. If we are not picky, best is a good option. And to exclude one or more elements from the legend, pass no label, or label is equal to no legend. Okay, so that's all. Okay, let me continue. So annotations and drawing on subplot. In addition to standard plot types, we want to join our own plot annotations, which could consist of text, arrows, and other shapes. We can add annotations and text using the text, arrow, and annotate functions. Text draws text at given coordinates X and Y on the plot with optional costume styling. So for example, what we want here is this text. Okay. This is a AX text. So annotations can draw both text and arrows arranged appropriately. As an example, we can plot closing S&P 500 index price since 2007. And annotate it with some of the important dates from 2008 and 2009 financial crisis. So we can most easily reproduce reproduce this code example in a single cell in a Jupyter notebook. So from date time, we can import date time, and then we have this figure, and we have the axis X. So we have created a blend plot here, and then we read in the data we want. Okay. So the next step for us is, okay, I want to create a plot. AX style is, I want G. Okay, yes. Okay, so you can see this is what I want. We have SPX, and we have the year from 1992 to 2012. So that is the result. And then we have crisis data, which are the dates that we think is very important. We put them in, this is actually a list. And so for data label in crisis data, then we annotate which label, and xy is equal to date. So date, because when I print date label, then you will see what happened here. So we have, okay, date and the label. So SPX as of date, which we want to add 75. And for the text, we want to add 225 for the arrow pops. So it should be black. And here is something to set the arrow props, and the horizontal element is left and the vertical element is top. So what we are doing is that we can check okay, so this is a three arrow, and also the text that we want to add here. And so we set title, we set X lim, Y lim, and so let's check what happened here. See, right now we have the title, and at the same time, we change the year to month, and for Y, we also change it. So that's what we are doing. In here, then let's go to the next step, which is, so to add a shape to plot, we create a patch object shape and add it to a subplot by calling x add patch shape. So because drawing shapes requires some more care, Matplotlib has objects that represent many common shapes referred to as patches. So some of these, like rectangle and circle, are found in Matplotlib PyPlot, but the full site is located in Matplotlib patches. So we have okay, which is very interesting, right? So we use the add patch to patch object shape. And if we look at the implementation of many familiar plot types, we will say they are assembled from patches. So this is how we use patch. Okay, so this one is bigger. And what's the difference here? So this one, okay, rectangular. Okay, which is pretty the same, and the circle is like this color. And then we have polygon, which is, okay, these are parameters in it. And then we draw it again. Only difference is this time we have figure size, right? We have figure size, so that make it bigger. Okay, so next part I want to look at is saving plots to file. So how we do it, which is pretty easy. We can do, okay, plot save fake. And there are parameters for us to set the DPI. So the file type is inferred from the file extension. So we use .pdf, then we will get a PDF. If there are a couple of important options we use for publishing graphics like DPI, which controls the dot per inch resolution, and bbox inches, which can trim the white space around the actual figure to get the same plot as a PNG with minimal white space around the plot at 400 dpi, we would do, so this part to add some add the parameters to make sure we can get the DPI we want. And the savefig doesn't have to write to disk. It can also write to any file-like object such as bytes IO. So there are many like savefig options that we can look at, like DPI, face color, edge color, format, bbox, box maybe, bbox inches. So for matplotlib configuration, it comes configured with color schemas and defaults that are geared primarily toward preparing figures for publication. Fortunately, nearly all of the default behavior can be customized via an extensive set of global parameters governing figure size, subplot spacing, colors, font sizes, grid styles, and so on. So one way to modify the configuration programmatically from Python is to use RC method. So for example, what we use is RC, okay, to set the figure size. And the first argument to RC is a component we wish to customize, such as figure, XS, XTick, YTick, grid, legend, or many others. So after that can follow a sequence of keyword arguments indicating the new parameters. An easy way to write down the options in our program is as a dictionary. So right now we have this dictionary here, and for more extensive customization and to see a list of all options, matplotlib comes with a configuration file, matplotlib in the matplotlib directory. So if we customize this file and place it in the home directory titled .matplotlib.rc, it will be loaded each time we use matplotlib. So as we will see in the next section, the Seaborn package has several built-in plot themes or styles that use matplotlib configuration system internally. So I mean, there are many beautiful actually styles in Seaborn for us we can use. So I always use Seaborn styles because I think the colors is, I mean, it looks natural, and it's beautiful. So I will use them. So I will finish this part, and the next part we will talk about plotting with pandas and the Seaborn. So in that part, we talk about line plots, bar plots, and we will talk about histogram and density plots and scatter and point plots and the facet grids and the categorical data and other part. So that's all. I mean, that's the main like plots we will use. So I'm very excited about the next part, which will happen in a few minutes. So see you later.